Well, hello everyone, and welcome back to Adrian's Digital Basement. This is part 3 in the Apple II clone repair series. In part 2, which I recommend you watch first, that was a doozy of a video where there were so many problems with the motherboard on this thing. It was a real roller coaster with ups and downs and everything in between. But I made some really good progress in fixing this board, but unfortunately, it's still not working. At the end of that video, after fixing a short under one of the slots and a short under some of the RAM, well, I loaded up a game and it still had issues. So in this video, I'm going to fix this motherboard. I can tell you right now, mark my words, it will be fully operational in this video, but there are still a bunch of problems with it, so there is a lot more troubleshooting to come. So settle back in your chair and get ready for another awesome roller coaster of a repair video with this motherboard. So without further ado, let's get right to it. Alrighty, so I created myself a little to-do list here for this video just to remind me of all the things we're going to be working on with this board. Obviously the first thing, as I mentioned in the intro, was that this crashes, well at least with Fat City, it was all corrupted and there's definitely something wrong there. In addition, when I booted up Fat City and was showing the intro screen, the colors were all off. That's a phase problem with the NTSC artifact color on this board, where what should be green or purple or orange or blue, those are the 4 colors of Apple high-res graphics, they were all out of phase and therefore they looked completely wrong. So I definitely want to try to fix that problem in this video so the composite output on this thing works properly. In addition, we had some problems with the keyboards. That's going to be pretty simple. It's just some of the Alps SKCC switches are bad. So we're going to get to a little bit of repair on that, maybe take some apart, swap them around. I need to see what I have in stock. I haven't actually checked for those. And the last thing on the list I want to talk about is the Apple II diagnostic ROM. Now, even though it's the last thing on the list, it's probably the first thing I want to talk about. This little card right here is an Apple II language card. It's a modern recreation, an open source one, and I have the diagnostic ROM installed in here. But unlike the diagnostic ROM you saw in part 2, well, we have evolved the diagnostic ROM and made it so much better. I think the best way to talk about this ROM is let's plug this into my Apple II Plus, which is sitting off camera here, and let me demo how this thing works. So here's my 48K Apple II Plus on the bench, and if we turn this on, it just works. There's a disk controller in here, even though it's not connected to anything, so it's just trying to boot up the floppy disk right now. But I can break out of there, and there's the flashing cursor. Here's that modern recreation of the language card for the Apple II Plus. Now, the original design of this was actually created by Frank, my friend Frank, who did the diagnostic ROM in part 2. And then this was remixed by Brad to turn this into a through-hole design. So it was much easier to assemble if you don't have SMD parts handy or your soldering skills aren't that good. There's a GitHub repo for this. I'll put a link to it in the description, of course. This thing uses static RAMs right here. So we have 2 8K static RAMs for 16K total. And just like the original Apple language card, there is a ROM socket here to hold a 2K EEPROM that replaces the F8 ROM, which is the boot ROM on the motherboard. And that happens to be where the diagnostic code lives. So I inserted a 2716 EEPROM onto here and I set the jumper so this is enabled. And let's put this in the computer so I can demonstrate how this works. Now this machine has a full complement of RAM and there's no issues with the RAM in here, it all works. So this diagnostic is not going to find any problems with the computer. So we turn this on, we get a little bit of a beep, and then we get a test pattern. Now what this test does now, and this was all pretty much written by my friend David Giller, who did the diagnostic ROM for the TRS-80 line of computers, is this is doing a full-on March U type of RAM test in the entire 48K of RAM. Now, because the graphics mode is turned on and there's a little bit of text mode there, you can see it sort of marching through and changing the patterns as the March test runs. In case you're not familiar about different types of RAM tests, the March test is basically considered to be one of the best RAM tests there are, especially as it's able to find things like page errors and other subtle problems with the DRAM chip. I won't get into the details of why that is, but there are articles written about this type of testing. In fact, I think March U was really talked about in the 90s as a way to really find these subtle bit errors, and that is the exact algorithm that's running on this system now. So it takes a little bit of time to go through all the different patterns and read and write every single byte of memory. Oh, and then there was a beep there to tell me that the RAM test was good. And now it actually just loops and runs over and over again. Now this will run until a fault is found, and we can simulate that by just pulling one of the chips out of the board. So these are the RAM chips on the Apple II. This is bank 0, bank 1, and bank 2. So this is the first 16K of RAM, then this is the next 16K, and then this is the top 16K. This first bank, bank 0, is absolutely necessary for the system to really run at all, because the 0 page and everything else is in there. But this top bank here isn't really necessary for, general operation of the system. So it's safe to remove one of these RAM chips here, and this would still boot into AppleSoft Basic without any issue. So we'll just pop out a chip. Oops, there it went. And when we power on the system, it starts running the test. And very quickly, we're getting a beep code here, and it says error 1, bank 2. I know it's a little bit hard to read because of this flashing text here. And what this is telling us by error 1 is that the bit error is on data line 0, or the very first bit for the processor. There's no way for us to flash or beep a 0, so we actually do 1 through 8 as the beep code. And then the bank number is 2, and it can be a possible 0, 1, or 2. And down here on the motherboard, the way the RAM chips are laid out is this is data line 0, 1, 2, 3, 4, 5, 6, 7. So the way this diagnostic will run is it will say 1, 2, 3, 4, 5, 6, 7, 8. So it's telling us there's a bit error in bank 2, which is this bank right here, bit 1, and the first bit, which happens to be data line 0, which happens to be this chip right here that I removed, which on this computer we can fix by just reinstalling the chip just like that. And now when we turn on the system, we shouldn't have any bad bits unless there's a bad socket or something, but nope, it's already gotten further along. Subtle types of errors with a March test can be found later on, depending on the patterns and stuff like that. So it could be that this diagnostic will run for a little while before it finds an error, or it could be really quick. Now, removing one of those chips results in all the bits on that data line to be always 1. So it's very easy for the diagnostic test to find that problem. But chips can have really subtle problems where they mostly work and there's like a bad bit just somewhere in the chip, or maybe it's only bad sometimes depending on what its neighbors are set to, stuff like that. And that's why all these different patterns that this is running through right now is really good at finding those types of issues. So with this clone motherboard, I want to run this RAM test on here because I'm suspecting that we have some RAM issues on here. Even though I tested in the Retro Chip Tester Pro all the RAM that's in the first bank here, or bank 0, there's a bunch of RAM in the second bank here, which the Retro Chip Tester Pro actually reported as being bad. But I found that the Retro Chip Tester Pro doesn't do the best job at finding 4016 chips that are actually bad. Like, it says stuff will be bad when it's not. And I think usually if it says it's good, it usually is good. So hopefully our new diagnostic ROM here is going to help us figure out what's going on this machine. Now, when it comes to this diagnostic ROM, we are still improving it and adding new features. In fact, the final goal we wanted to do is test the 0 page in the stack first using the March test, and then test all the rest of the memory with the March test, and then report back any memory locations that are bad, like in a list form, not just stopping on the first one like it's doing right now. But David, who's doing pretty much all the programming for this thing, is doing it in his spare time. He has a full-time job and a family and all that stuff. So he's just trying to fit it in around his schedule, and I've been putting a lot of pressure on him to get this to the point it is right now so I could have something to use for this video, because I knew that this type of a diagnostic would be very helpful at trying to troubleshoot this machine. Remember that in part 2, I booted up that disk-based diagnostic and it ran through, well, all the memory and said that it was all fine, when that's clearly pretty much impossible because of that graphical corruption we saw in the game. But I think the problem is that Apple's Cylin disk test is using a very primitive type of RAM test, which does not find bit errors. And that's unfortunately the case with a lot of really simple RAM tests. They are just not good at finding subtle problems. But the March test, which is what's on here, is. Now, before we jump into running this code on this machine, there's one quick thing I want to add is in the first and second video, I struggled a lot with the composite output of this thing and the RetroTink, as I usually do struggle with the RetroTink. There were times I noticed during editing where I was getting these patterns on the composite video output, but the problem is the RetroTink wasn't giving me a good indication of what we were looking at because the image was super blown out because of the weird auto gain that it has. So I was pretty frustrated with that, and I ended up wiring this motherboard up so that we can use, hopefully it's in view there, the RGB to HDMI. Now, I love the RGB to HDMI, and yes, it absolutely is compatible with the Apple II line of computers, but for the early ones like the 2 Plus, you need to wire it up right into the motherboard. And there weren't even plans on how to do that, but I have gone ahead and I figured that out, and here it is. So I actually added a little pin header here in the little proto area, and then I wired up the RGB to HDMI signals to the correct chips as based on the Apple II schematics. And we look at this side of the board, there are 10 pins right here, with pin 1 being on the bottom left corner, which matches up the way it is on all the ICs. And then all I need to do to connect it up to the RGB to HDMI is use one of these serial port headers. And we just plug that into the header on the motherboard. And then this is the RGB to HDMI input, and I have this wired up for CGA or EGA. And we just connect this right up, plug in the power connector. And then when I power on the computer, instantly we see what's going on. And we right away have an issue. So the computer obviously booted. I don't have the speaker hooked up, so you didn't hear the beep, but we have some page errors. I would not be surprised if we have like a bad socket or something like that with one of these chips that handles the RAM multiplexing. Let's just push on everything. And we turn it on, and look at that, it's back, it's working. So as you can see, we have pixel perfect representation of the Apple II, and the best thing is when I turn the computer off and back on, it's just instantly there. There's no like lost signal or syncing or anything like that that goes on with the VGA adapter I have or the composite video. So this is how we're going to be doing the rest of this capture, and I can assure you that what we're seeing here on the RGB HDMI is exactly what's coming out of the composite video, because the video data going to the RGB to HDMI is this signal right here, video data. It's B10, the chip B10, pin 5, which happens to be the serial shift register for the video generation. I'm also connected to the composite sync that comes out of C13 pin 8. And then there's also a signal here for text mode, and that is B13 pin 13. And that signal is used by the RGB to HDMI to turn on the artifact color decoding. So while the Apple II is displaying graphics, it will actually be in full color. Now, I do need to point out the one caveat is that color phase issue that we saw in the composite video last time with that title screen. That is not going to be visible to us in the RGB to HDMI. So we'll have to address that problem later once I get this machine fully operational. Okay, so the system is obviously working, but you saw that when I turned it on originally, before I pushed on these chips, we had some kind of a page error. And the problem went away when I pushed on the chips around the DRAM. So that pretty much tells us that we're gonna have some socket issues on this machine. In fact, let's just like manipulate the motherboard here. I'm just gonna like bend it and stuff, and let's see if that problem comes back. No, that problem is not come back. Okay, here's that Dis2 controller, and it goes to a floppy drive that's just off camera here. Let's plug this into slot 6. I have Fat City in here. Let's see, let's plug in the speaker as well. It is booting. Let's see what happens. Okay, so it's exactly like it was before, where we don't have the extra colors. The green around the text, or sorry, okay, it's crashing in exactly the same way. The bottom of that screen there where it had text, that should have been green, like green grass. And it was obviously not. Let's unplug the speaker here. Let's power cycle the machine again and look at this one more time. So as I was saying, that picture, because I'm very familiar with that game, when it boots up, along the bottom it should be green like grass, and there should be some purple mixed in there as well. I can't remember where that is, but we're only seeing 2 colors. And that's a really good indication that there's probably a problem with something in bit 7. And I happen to know that with the Apple II graphics mode, the high-res graphics mode, to enable those extra 2 colors, or to switch between green and purple, and then the other color, the orange and the blue, you need that extra bit 7 to facilitate that pixel shift. And you can see on this screen, we are getting some green on the side, but we're missing something on the bottom. So this is really giving me an indicator that there's a problem with the 7th bit on the memory, on the upper memory. I'm pretty sure this first bank of memory is fine because all of these chips here tested good in the Retro Chip Tester Pro. Hopefully you can see that when I inserted all these memory chips into here, there are a bunch that have X's on them. This one has an X, this one, this one, this one, this one, this one, this one. In fact, every single one in this middle bank has an X on here because they were all ones that tested bad in the Retro Chip Tester Pro. Now, I decided in part 2 just to put these in the board because I didn't really trust the Retro Chip Tester Pro in telling me these chips are bad. So I think it's time to insert the diagnostic ROM here, and let's see what this thing says on this machine about the memory chips. So we're gonna pop this in. I left the speaker unplugged. We don't need to hear the beeps and stuff that it's gonna do. And here it goes with the RAM test. Okay. Bank 1, error 8. So it's telling us this chip right here is bad. And that actually coincides exactly with what I was thinking when it comes to that color not working correctly on that title screen. Now in part 2, I mentioned that I couldn't find my bag of tested 40116 DRAM, and I still can't. I have like a anti-static bag that's just filled with it. But what I did is I scrounged everywhere in the basement, and I was looking for every piece of 40116 I had. And then what I did is I put the chips into the Apple II Plus with this diagnostic ROM in there, and I tested to make sure that the Apple II Plus said that these chips were good. And I happen to have found this many good 40116 chips, which is really nice. A couple I did find did test bad in the Apple II Plus, so that kind of confirms the diagnostic test we wrote is working. Okay, so I'm going to take out this chip that has an X on it, and we're going to replace it with one that I have tested in the Apple II Plus. Okay, and with that in the board, let's turn this on. Let's see what the diagnostic test says now. Hey, so it's running a lot further, isn't it? Hey, this is good. This is good. Oh, okay. It just said all the RAM is good. That's unbelievable because remember, all of these chips here have X's on them. So the Retro Chip Tester Pro said they were all bad, but that's clearly not the case. So I think we need to test out the game again and let's see if, well, it completely works now because I'm assuming, or hoping at least, that should fix the problem. Plug that in. I'm going to plug the speaker back in so we can hear the music. Okay, there it is, and the color looks good too. Uh-oh. Okay, so the computer just froze, and it happened when I just touched the motherboard. It's obviously having issues there. So let's power cycle it again and let's see what happens because maybe that was a fluke. But when things crash like that with subtle touching of the motherboard, I just bumped the edge and the speaker's unplugged by the way, but let's see if we see the animation. When things like that happen, that just screams issues with sockets. Let's see if it can get past this without any corruption. Yep, perfect. And get to that next screen, which should say keyboard or joystick. Yeah, there we go. Okay, so the machine is literally running at this point. Well, I'm going to plug the diagnostic ROM back in because this thing just loops continually. And this is a really good way for me to see if the machine is flaky. So I'm just going to like lift the board up here. Yep. You see that? I tweaked the board slightly and the graphical screen got very corrupted all of a sudden. So we either have another intermittent short on here. Let's try that again. We either have an intermittent short or we have just some bad sockets. Yeah, right away it says bank 2 problem. And look, moving the board around, the text is all over the place. So I am thinking at this point, all there is left for me to really do is go through this motherboard and take out every single chip one at a time and put Deoxit and then very carefully reinsert the chip into the socket. I'm going to have to Deoxit this entire thing. And I just don't think there's going to be any way around it. And the reason why is these sockets that are in use on here are single wipe and are terrible. They're absolutely terrible. And unfortunately, sometimes these sockets get damaged and the only way to fix that, if you find one where you touch it and it's intermittent, is just replace the entire socket. But I think going through the Deoxit route is going to be the right thing to do. And I'm just going to start right here on this chip. And I'm just going to go through and I'm going to do them all. It's going to take a while. I don't need to do the sockets that I've changed out. Like these are the round hole, those are fine. But the rest of these, yeah. Now the one thing I want to add is with these sockets with the little tiny holes, it's very easy to fold over the pins when you put the chip back in. So I highly recommend you do something like this to straighten the pins and make them go in as easily as possible back into that socket. And then of course you need to keep track to make sure that you insert the notch the correct direction and everything like that. I cannot stress enough that if you bend a pin putting these back in, you're going to create another fault. It can be very difficult to find those bent pins, barring taking out every single chip again and checking to make sure. So just be super careful. All right, well that was quick. I've only done the first row here, which doesn't even have all the chips. I didn't even do the character generator because I don't think that's a problem. And I already ran into an issue. When I turned on the system, we had a black screen. And look, it's this chip right here. If I just touch this ever so slightly, we have all sorts of issues. In fact, if I push down on it, look at this, nothing. We just get a black screen. But when I let go of it, you know, it seems to be working. So clearly we have an issue here, either with the socket or the IC. Now this is a dual wipe or single wipe. It's a single wipe socket. Now these are especially junk. And looking at this chip as well, it's got legs that are not great. Like, see how there's like a black oxidation on there? But I mean, it should work, but it seems like it is very touchy. Nope, look at that. It's very, very unreliable. Well, maybe that's why we had that corruption when I first turned on the computer, as well as this socket right here. And with the chip out, the socket itself is incredibly loose and flaky. So I'm gonna swap this out with one of these sockets like I did on the keyboard connector here, and let's move on from there. Okay, the socket just fell out of the board. I was like pushing it with my finger, so that's one way to get it out. And I might as well inspect for any of those bad pads with a short, and no, everything looks completely fine under there. All right, moment of truth, with the new socket in there and the chip reinstalled, we have nothing. I wonder if this is a problem with the clock circuit, because with those transistors. Oh, yes, okay, it was. I gotta fix those too. I should probably just solder those directly on the motherboard, right? Because this is like, it's super unreliable. How about oh no! There's some other problem. Oh no, really? Which chip is it? This one here? I mean, I'm trying not to bend the whole board. I don't know. I don't think it's the chip that I just took out though. That one was definitely problematic, but I'm pulling on that one and it's okay. There's some issue, I think, in this area, although it could still be on this row actually. Oh, wait a second. I think it's on this next row up. All right, let me go and deoxit the stuff that's on the next row here, and let's see, let's see if this fixes anything. You know, sometimes things are just, they're not easy. Nothing about this motherboard has been easy. Nothing. Everything about it is a pain in the butt. So I've done these 3 rows, and let's turn it on, see if we have a working computer. We do not. Let's fiddle with the crystals over here, or the transistors. Okay, there we go. Do we still have an issue? Hey, this seems fixed. So when I tapped on this second row here, it was still having issues. But doing this third row here, yes, yes. So definitely that socket down here needed to be changed, 100%. But the Deoxit does the trick. That doesn't mean I don't need to do the rest of this board though, but this is, oh no, look, it's, oh no, no, no. Which is it that's causing this issue? Which chip? This is super annoying. I was talking to Frank IZ8DWF about this problem, and he was like, you just might have to change every single socket. I was like, that's not, oh wait. Oh, that was just me pushing on the board. You know, it really seems to come from like bending the board. Look at this, when I push down the corner here, could this be one of those shorts? This could easily be one of the shorts. While I'm pushing it down, if I power cycle it, hey, it looks exactly like it did when we first powered it up. And then when I let go, it's okay. Oh man, there's got to be a short. This has got to be one of those shorts. I don't see what else this could be. Pushing down the board right here causes it to appear. And the problem is here is that, like, once this thing gets mounted in the case, you know, it's attached to the base plate, that could easily cause this issue to appear. What I'm thinking here is that we may need to kind of force this to happen by pushing down the board right here, look for the faults, or try to like figure out what the fault is based on, you know, obviously this is creating like a page error or something because it's basically repeating some of that text. So we're losing the granularity into the DRAM when it comes to the pages. So exacerbate this fault and then try to figure out from the schematics which are the chips that are handling this particular paging stuff. Like these are got to be the multiplexers or whatever for the DRAM. And then start looking around for shorts. But when I let go, it goes away. All right, what I'm going to do off camera is I'm going to do the rest of the motherboard with the Deoxit, and just to kind of get that done. And then we will focus on this particular problem. And we're back, and I've gone ahead and done Deoxit on every single chip on this board, well, except for the ROM chips. I didn't touch those, or the CPU, or the character generator. Everything else, I did Deoxit, and I discovered some stuff. I found a chip that I had never touched before actually had a pin that was bent. And by bent, I mean it was curled up underneath the IC. It was this one right here. But obviously it didn't really have an effect on the system because it seemed to be working properly. But it just shows that someone has been here before. But you saw that the computer has a fault right now. And it's that same fault that we were getting before when I pushed down on this part of the motherboard. I don't think this is actually a short like I thought it was in this area. No, I figured out exactly where this was because every time I take one row of chips out and do the Deoxit, I would turn it back on after the fact. And there was one row specifically that after I deoxed it, it is now like this all the time. And it was this row right here. And in fact, I found this socket that is bad, and it is this one right here. This is the socket. Now, if I hold down on it, turn it on, the computer works, but as soon as I let go, it goes bad. So I need to swap this socket out. We'll take a look for any shorts underneath there, like those bad pads. And hopefully, this is it. This machine may actually work after this. Just maybe. Socket is replaced. Chip is back in the board. Let's see if this works. We have no signal. So let's check the little transistors down here. Okay, it's working right now. All right. How about if I just bend the whole board? Oh, we may have finally, a motherboard that works. Unfreaking believable. Wow. Okay, I don't want to count my chickens before they've hatched. I'm going to reinstall the expansion slot here. Hopefully this thing is stable. I'm scared. I'm going to reinstall the expansion slot, which I happen to have right here. And then we'll just run it through the diagnostics. I think the best thing I can do probably is just let this thing run for a long time, especially if I like manipulate the motherboard. I'm just looking at the screen there. I haven't seen any kind of corruption. And then we'll play some games. See if this thing can run things properly, like Fat City. Okay, the slot connector is back in. We're ready for some burn-in testing. So I have the diagnostic ROM in the motherboard here. Let's power it up. Okay, so I have the speaker hooked up here so we can hear if this thing errors out. If it decides that a bad bit is found because like one of the chips is bad in the socket or whatever, then we'll hear beeping. But I'm gonna talk while it runs. So let's take stock of everything this motherboard has put me through. The first thing that was bad was the transistor over here in the video section. That thing had shorted to prevent any kind of video output. Then we found that the reset circuit transistor, which I think was this one right here, was also shorted. So that prevented any kind of reset, or just making sure it didn't freeze. Okay, it's still running. So we had to change this transistor over here as well for the reset circuit, so that way the reset would work. I proactively changed this transistor here, the color killer circuit, because it was the same exact transistor of the other two. There were 3 total on the board of this 1815 transistor. So I just changed that one proactively in case it failed in the future. It would just prevent the color from working, although it wouldn't have caused any issues on the motherboard. Next up, the crystal oscillator, which was over here in this corner of the board, has been very flaky. And I just noticed when I was putting the slot connector in that one of the transistors had one of the pins out of the little socket that's on there, and it was just sitting there on the side touching. So I think that's why it's been so flaky. So I just made sure that it was in there firmly, and okay, there, that's the good beep, by the way, and now it's looping again. So I just made sure that it's in there properly and the system seems to be working. Next up, it turned out we had a short between a data line and an address line. And it turned out that it was one of these slot connectors. It was underneath, it wasn't the slot connector itself, it was underneath on the motherboard. The pad was misshapen or whatever, and it just happened to be touching the trace that ran right next to it, and that was causing a short. I can't imagine that it was like that from the factory. It must have been just barely, you know, not touching, but then maybe putting cards in and out over the years caused it to kind of like bend the PCB, and eventually it touched. So I ran a knife there between the trace and the pad, and then that cured that problem. But the computer was still having issues, and it was like RAM-based problems, and it was very tricky to track down, as you saw in the last part, which was the long part 2, where I really tried to find that issue. And it turned out to be another misshapen pad underneath one of these chips here, and it was this RAM chip right here, and it happened to be shorting, if I recall, the data out pin to the read write pin, or the write pin that goes to the DRAM. So anytime the output of this chip was down at 0, it would cause all the RAM to get corrupted because the write signal was now pulled down to 0, and write is an active low signal. So that means that anything on the data bus that was happening, the RAM will just save that into memory no matter what the address lines did, and that completely corrupted the system. Pretty tricky to track down, and in fact I changed out this socket first thinking it was this one, but I didn't use my brain because I used the same methodology with my multimeter to find that short, which was exactly the same as what was under the slot here, and it turned out that it was this one here that was the problem. So I ended up changing out one extra socket. When the computer was fully reassembled and everything was back in, we still had some problems with the RAM, and that's because all of these chips here in the middle bank had tested bad in the Retro Chip Tester Pro, but with the new diagnostic ROM, which we see running right now using a March U test, it detected that only one of the chips was bad, and it was this one right here. So I took it out, it's sitting right here, there it is. I took it out, replaced it with a new tested good chip, and the computer was working a lot better. All of these chips had X marks on them because they tested bad in Retro Chip Tester Pro, so I used alcohol to erase all of the marks off all the chips. So all this RAM appears to be good because this test is looping here, and so far so good. And I can actually pick the motherboard up and move it, and it's not crashing. And it seems to be working. So I think we're actually done with the repair of this motherboard. That was so much work, but it was really fun in the end. And I mean, there's a positive here. We got a diagnostic ROM out of this. Of course, I'll be sharing that to GitHub, and as we improve it, and hopefully we're gonna add new features, this will be a better and better dead test type ROM for the Apple II, where you can quickly and authoritatively test all your memory, and it will tell you exactly what chip is bad. If anyone wants to contribute to this diagnostic ROM, please feel free. I will put a link in the description below. This is open source software, of course. It will be on GitHub. Anyone can fork it, make changes, make it better. Please do, because the Apple II has sorely lacked any kind of diagnostic ROM. So it's absolutely amazing, at least for me, that one now exists to help you validate that your Apple II is a good, solid, reliable computer. Now, if we go to my little list here, so crashing game, that is fixed. Diag ROM, we obviously talked about that. Now we need to sort out this bad color issue. I'm gonna have to plug in the composite video into here, and let's take a look at how the colors look when we compare the RGB to HDMI to the composite, because they're not quite right. Now I have the disk controller here. Let's try and boot the game. But I think what I'm going to do is I'm going to plug it into the slots in the area where I just did that desoldering work, or that resoldering work. I think this was the one, and let's just make sure that that slot is working properly. All right, it is booting. I may need to deoxit these slots because I think when we first tried this card, it didn't work. And in fact, right now, the disk is spinning and yet it's not actually loading anything. So what we're gonna do is we're gonna deoxit these slots here. Oh, I just realized something. This game almost certainly will not work plugged into slot 5 or 4 or 3, or whatever I had it in there. It's just not gonna work properly. So I'm just gonna plug these in backwards and forwards here a bunch of times. Let's move the mouse pad over so it's underneath the slots. I only put the Deoxit on like one set of pins, but flipping the card around each way should help spread that Deoxit to both sides. Okay, I think this slot should be a little bit more happy now. So as I was saying, a lot of these old games, they just do not run in any slot other than 6. They'll start to boot, and then what happens is they're hard-coded for slot 6, so when they try to continue booting, it goes to slot 6, and of course slot 6 is not connected to anything at all, and they will just hang. So if we turn this on now with this in slot 6, this should just boot normally, and it is. This drive is accessing, and we should get the Fat City screen. I'm going to unplug the speaker. There it is. It looks good. Let's just make sure that it runs through normally. There it is. It's knocking down the letters. And then obviously you can see the purple and the green that I was talking about. That was not there when we had that bad RAM chip in. Okay, that is how it should look. All right, so on the RetroTink, I just switched over to composite video. Now when we turn this computer on, you can ignore any kind of like bright screen or whatever we're going to be seeing. Come on. There we go. We should have a picture now. The colors are going to look all wrong, and they do. Now, there's a little adjustable capacitor right here that allows us to tweak the color. So I'm going to turn on this, and you can see it's turning, but it just spins forever, and I cannot adjust this in where the colors look correct at all. So no matter how that is set, the colors don't look correct. Now, over here on the crystal oscillator, there's also a master clock adjust, and everything on the system here is derived from this clock. So if this is out, then that will affect the color. The thing is, I can change this, and we should see a color change, but you see we just lost the color, and that's because the color burst for NTSC is derived from this master clock, and if I turn it too far out like I did there, the color burst is lost, and it no longer sees it as a proper color signal. So I'm just going to kind of set this in the middle, because I don't know what else to do. And we have a problem here where this just cannot be adjusted in correctly. What I brought up here are schematics for this revision of motherboard. Now, of course, this is a clone, but it basically seems to be copying this revision, which, according to this here, is revision 0, like the earliest revision. So at least the color circuit looks like this. So the color burst comes out of this gate right here at B12. It goes through a resistor, there's an inductor to ground, and then we have 2 capacitors to ground. There's the adjustable, it says hue adjust, 5 to 50 picofarads, and then there is C2 57 picofarads. Well, I noticed a potential problem when I was looking around the board previously when I was inspecting it. This was like another day. Here is the adjustable, or the hue adjust, that's the adjustable capacitor, 50 picofarads, or 5 to 50. But right there is the 47 picofarad cap that is there on the schematics, but doesn't seem to be installed on this board. Well, I have a feeling that without this installed on the board, it's not going to work. This adjustment here is not going to be able to bring the color in properly. And this part's missing. That means that the color was never right on this. And whoever used this computer back in the day, I guess just thought Apple IIs have weird colors, or maybe this clone was just junky and didn't have the right color. Let's install that part. I need to go find one. I think I should steal one off another board or whatever. And then let's see if that helps the issue. Well, I was looking through my little parts bin here, and I couldn't really find any 47s. I found like 10s and 15s and stuff like that. I guess I need to order some stuff. But I went in my junk bin, and I found this old network card, and it has a bunch of 47s. And I took one of them out, and here it is, 47 picofarad. I figure that's close enough. Hopefully the range of that other adjustable capacitor will give us the color we desire. Everything is back in the board, and we're ready for testing. Oh, ignore that it's all blown out. This is the RetroTink again. Just look for the correct colors. I got my little adjustment tool here because, oh, that doesn't look good. Maybe we can adjust this. Oh, hey, there it is. Yes, it adjusts properly. Oh, sweet. Let's just power cycle. I want to see that again in those glorious Apple II colors. Remember that 1977, well, about 78 when Wozniak added the 2 extra colors. Amazing. There weren't many color computers at that point. And yeah, that looks great. Oh, so that fixes, where's my checklist? That fixes the last item there is with the motherboard, bad color. I can't believe it. This thing is completely freaking working. And I suppose we could say that it's enhanced as well because, of course, I added this little cool header right here so we can have pixel perfect color with the RGB to HDMI, and we're not reliant on that not so great artifact color that's coming over the composite video. And yeah, the colors are obviously far richer and deeper when we're looking through the RGB to HDMI, but I have a feeling when I plug a Commodore 1084 monitor into this motherboard, the colors will look completely good and with no issues whatsoever. In fact, remember the color fringing in the text mode we were having because of the color killer circuit? Turns out that when I hooked up a Commodore 1084 CRT monitor, there was no issues at all with the color fringing. It was really only happening with the RetroTink and with the little LCD monitor that I was using. Actually, I was using that on the Apple II when we started this video, and there was color fringing even on that machine. And I think my Apple II Plus motherboard has the extra gates seen right here, which basically looks at the text mode, and that runs through this little gate right here, and that disables the color burst entirely while in text mode. And yet, unfortunately, there is still that color fringing on some of those LCD monitors. That's just one of the problems and the side effects of the Apple II composite video. It's kind of non-standard, and a lot of monitors don't like it. So it's one of the reasons why the RGB to HDMI, like we're showing here, is such a great solution, or that open source VGA card that I showed several videos ago, that is a great solution as well. So I really gotta say that I am so excited that this thing is fixed. And just seeing this game boot and looking good, it makes me so happy. I mean, I just can't believe it. This motherboard had so many difficult to find faults. It really, really put me through the ringer. And simply amazing that when it comes to semiconductor faults, one bad RAM chip and 2 transistors, and that was it. Everything else were physical problems on this motherboard, but as you can see, we're fully operational now. So I guess it's time to attack the keyboard, as to say right here, choose for keyboard, so we can get this thing back together. The footage of the work I was doing repairing this keyboard was actually originally right here in this video, but this video was really getting super long, so I decided to cut out the entire keyboard repair part and put it in a standalone video on the second channel. So that video will already be live by the time you're watching this, so maybe you've already seen it, but if you haven't and you want to watch it, you can check that video out. I'll put a link in the description below. But I repaired the keyboard, and right now we're about to plug it in and actually test it out on the Apple II clone, so let's do that now. All right, it is the moment of truth. The keyboard, refurbished, is connected up to the motherboard here. Hopefully the motherboard still works because it's been a couple days since we finished the repair. Let's turn this on. Oh, I have the diagnostic ROM card in there. That's what that was doing. Let's turn it on. Okay, there we go. Power light's on, so that's good. I'm just gonna go through all the keys and make sure they work. Alrighty, we have success. Every key is working properly, including all the ones in the bottom here that were having issues. That is very exciting. I'm pretty sure if I hadn't fixed that bad trace, we would have had some keys down here that weren't working, but definitely swapping out those key switches resulted in a fully functional keyboard. And of course, because of the rust paint here, or the rust conversion, it doesn't look so ugly. That is freaking awesome. So this means on the little list here, the last issue is corrected. So that is freaking great. So I think what's left to do now before I put this all back into the case is I'm gonna put the disk controller back in. I'm just gonna run this machine through some more of its paces. I just wanna make sure that the motherboard is really actually fixed, because I have to be honest that I am scared that there are more faults in this thing, more intermittent faults that maybe I couldn't detect with the testing that we did before. Where I left off earlier in this video, when the motherboard had been repaired, I actually put the diagnostic card into the machine and just let it run through, looping through those diagnostics for about 6 hours while I was doing other things and editing the video. And I could hear off in the background the beep of the test telling me that, you know, it had completed a successful run. So that was really reassuring that this machine ran for hours and hours and hours without a single fault. But that doesn't mean, now that it's had time to cool off and it's been a few days, that another fault has developed. So let's plug in the disk drive and put this thing through some more paces. Floppy drive is connected. I have Fat City still in here from last time. Let's power this on. Let's see if this is working. Hopefully nothing has changed. Hopefully. Oh no. Oh no. Okay, I'm gonna unplug the speaker. All right, clearly we have a fault again. Oh no, I can't even believe this. Like this, no. Let's see if the game even works. I'm supposed to push K for keyboard. Oh no, no, no. There's clearly something wrong. I mean, it's funny it's not crashing, so that's good, I suppose. But look at that. What is happening? The flickering of the little thing there. Oh no, this screen is a complete, and the computer just crashed, so it just rebooted the game. Okay, so I mean, it ran the diagnostics for like 6 hours nonstop with no issues. And clearly we have a fault again. Oh, I can't believe how close to the finish line we are. And yet, just can't get over it. At least the keyboard is fully functional, so that's great. I'm really excited about that. But I think first thing to do is let's put this diagnostic ROM back in the machine and see what it's telling us. Okay, we are ready for testing here with the diagnostic ROM. Error 8, bank 0. So that's telling us that this chip is bad here, but I don't really believe that because that chip, I mean, that was working before, we've tested it, and error 6, bank 0. All right, so I have a really hard time believing that we have 2 bad chips on the first bank here. And it looks like this test, error 8, bank 0 again, it looks like sometimes the test gets further than other times. It does seem to really point to this chip. I'll take it out and I'll just swap it with the one right next door here, and then we'll see if that makes a difference. I'm pretty confident these chips are good, and I think there's something else going on that's making it lie about what's actually wrong. If this says error bit 0 again or bit 8 again, then we know, yeah, it does. Okay. So clearly that's not possible. I'm thinking something else, like one of these marginal sockets somewhere is causing this. I think what I'm gonna do is I'm just gonna power cycle this repeatedly, and I'm gonna write down the bits that come up as bad. I wanna see if it's like only these 4 bits, or if we're having issues over on these bits, 0, 1, 2, 3, or as the diagnostic would say, 1, 2, 3, 4. So this is weird, I'm on the 8th or 9th power cycle. Now the test is just running without any issue. Very suspect. We'll let this run for a sec. So far I've had 8, 7, 6, 4, 5, 6, 6. Oh, there we go. 7. Oh, and bank 1 now. Okay, so 7 and 1. Every single failure before has been bank 0, and now it's telling us bank 1. All right, well, unfortunately, we're kind of back to square one again because this is an interesting fault where obviously this machine ran the diagnostic for hours and there were no problems. And maybe that's heat related. Like if I let this thing just run for a few hours, the problem will go away. The thing is, I don't want the problem to go away. I want to be able to identify which chip is bad here so that we can try to fix it. Well, at this point, I'm not really sure where to go. So I think I'm going to go to the documentation and start going through the RAM section again, and I'm going to actually look at the DRAM part of the circuit, and I'm going to specifically target those chips. And I'm probably going to start with the CPU and the 74LS245 here, because these 2 chips, obviously, any DRAM interaction, it's the most important that those are working properly. And we'll kind of go on from there, and I'm going to do a jump cut because we've done so much troubleshooting on this thing, and I'll report back what I find. All right, we are back, and I think I found the problem, actually. So I was racking my brain trying to think of, like, what could be causing this error, right? After we had everything working properly, and then, well, the machine seemingly broke after I let it rest. Well, remember how this middle bank of memory here was all bad chips? Well, I had them marked bad because the Retro Chip Tester Pro said they were bad. Well, I decided to take them all out and put in known good tested chips from my little stash here after I tested them on the Apple II Plus. These here are the Siemens chips that I took out of the board. I think that fixed it. So this is already looped a couple times as the original test here on my language card, and there's no errors. I think the ultimate test is, let's put the Fat City game back on here using the disk controller, and let's see if this fixed it. If this was the problem, this was my own fault here because, yeah, okay. Let's unplug the speaker there. So there we go. Those chips which it said were bad, I guess were bad, and very marginally so, where essentially they were running perfectly for hours and hours and hours. And now we can hit keyboard here to run the game. I do have the keyboard connected, and there it is, Adrian. Let's see if the game is working here. I forgot how to play this. There we go. And then we can go up and down. There we go, up and down. So, oh, okay, well, okay, let's not jump to conclusions quite yet. So it crashed. We still have Siemens chips up in this top bank here that definitely said they were bad. And I'm wondering if I should get those out as well. I've gone ahead and replaced all the chips in the top row except for these two Mostec chips, which I'm pretty sure tested good. There were some Siemens chips mixed in here that had X's on them, and I'm kicking myself for erasing those X's because I just assumed the system was working properly, so therefore those chips were good, but seems that's not the case. Let's hope now with this new RAM in here, I mean, it's not new, this is old, these are old chips. Let's hope that that game works perfectly now. Let's give it a test. Okay, so I've introduced a problem that is worse than before. The game doesn't even start now. With the diagnostic ROM installed, oh, right away, bank 2, bit 7. That's this chip right here. Well, let's see, maybe I bent a pin while installing it? No, every pin looks good on there. All right, well, we'll just use a different chip. This is interesting because this chip that I took out here, it has a tick mark on it, a check mark that is. I checked the chip in the Altitude Plus and it was working. All right, well, the diagnostic seems to indicate that it's working. I'm not going to rule out this chip though. Maybe that socket is bad. These are those silly marginal sockets. Let's switch back to the floppy drive here and let's see if the game runs now. It's loading. We're back to the same problem we had before. So it was almost like a fluke that it ran that one time. Yeah, this is looking just as bad as it was. If I do keyboard here, yeah, this basically looks identical. I just replaced the two Mostec chips in the top. That didn't do anything. So the fact that it ran once and then broke was whatever intermittent fault is on this motherboard still. So it's not the RAM. I falsely accused this memory here, so I'm glad I didn't like throw the chips away or whatever. It is some other fault. And it's interesting because it's such a repeatable problem. So if I can figure out what the fault is, I should be able to fix it without too much trouble. And it's interesting, so loading the game here, look at the graphics. It looks exactly like it did when it crashed, when it was running properly, and then broke. So what exactly is causing this? There's something else going on with this machine and I don't know what it is. I don't even know where to start with this problem. Well, I've been poking around a little bit and if we turn the computer on here, I have Epic Summer Games in the machine and it doesn't work in a very similar way to Fat City. So the game's not crashing. We're not seeing all the colors. So there seems to be something wrong with the display circuit. So we're only getting green and purple and we're not getting the other colors, we're just getting this white. So it's almost like the pixel shift part is not working. And I'm wondering if there were multiple faults on this thing. I don't know about the RAM. Obviously, I'm still running all this replaced RAM. I have the language card in here, so this game needs 64K. But clearly we're getting a problem here. And I think this is what's affecting Fat City just as much. That boot screen there has a lot of orange and blue on it, and those two colors don't work. And we end up just seeing, well, little flickers of it there, but we're just mostly getting the green and the purple. With the symptoms we're seeing, I think this is the relevant section in the manual here, or in the circuit description. So orange blue is selected with, I don't know, a signal coming from A11, and A9 is the data selector that can go back and forth between the two types of color signal. So looking at the board, these two ICs right here are the relevant chips. Let's fire it up and I'll fiddle with those sockets and we'll see if that changes anything. All right, so A9 is actually one of the sockets that I changed already. So that one I'm moving around doesn't do anything, but A11, whoops. I just pulled the chip out of the board accidentally while the computer was running and that didn't seem to have any effect on it at all. And with the A11 back in the motherboard after I straightened the pins, is this any different? Oh, okay, so we're getting the colors now. What the heck is going on? Seriously. You saw it flash there for a second, right? Where it kind of messed up. Aha. Okay. Which chip is it? Is it A11 or is it A9? It's got to be it's got to be A9. And A9 actually right here, this is one where I actually replaced the socket before. Whoops, I just dropped the chip on the floor. Here it is actually in my lap. If we turn it on, we're just getting a complete white screen. The system is trying to boot though. Kind of has me wondering though, is this IC possibly bad? I mean, I don't know. Let's put it back in here. Let's see if that does anything. We have a display at least. There it is. It's all working now. I mean, I know I have that socket in the board properly. Oh, this is a tricky one. This is a tricky one, everyone. I went into my spare parts and I found a new LS151, which is this chip, and I found an LS74, which is the other chip here. Let's try this 151 in here first. Power this on. See if we have intermittent issues. Of course, the problem kind of went away right before I tried swapping these chips out. Okay, so Summer Games is looking good here. Let's fiddle-faddle around with this chip here. Not seeing any issues. It's just working. It's really not reassuring. It's really not reassuring at all. Now, it goes without saying, if I put Fat City in, this thing's going to work. And you know what? The symptoms, at least for the graphical corruption, were right in front of my eyes the entire time. We were only seeing the green and the purple on the Fat City's flash screen. Anything that was orange or blue was just white. And there it is. It's actually working now. Now, as for the 151 that I took out of this motherboard, doesn't have any corrosion on it. The chip looks fine. I mean, it obviously was working kind of, and it's a brand new socket, so I don't think that's the problem. And if this were like a short on the motherboard, then pushing on this or moving it or something would cause some kind of flickering there, which we're not getting. Now, of course, we still have the problem with the RAM not working. And I've switched out all the RAM. It's still that swapped out stuff. Let's put it back on the diagnostic ROM here. Let's just see if this test is running now. So just to refresh everyone's memory here, this first bank is entirely RAM that we had on this motherboard during all of the testing here. And then this bank here, I replaced all the chips except this chip, which we changed out earlier in this video. And then this bank, I've also swapped out every single chip with known good tested chips. So I think at this point, what I need to do is just replicate what I did last time, which is let this motherboard really cool down and then run this test again and see if I still get those random errors. I'm not totally convinced that all this Siemens memory that I took out, and there's some on the disk drive here, is bad. Pretty sure whatever's going on with the video, it was two separate problems. So with Fat City, the way it was looking was something to do with these chips here. I'm not sure I even fixed it by swapping out this chip here, but we'll leave the new one on, the one from my spare parts. We'll see if that fixes it, but I have to say I'm more concerned about those random bit errors than anything else. And these chips here are strictly used for display output and have nothing to do with the memory here. So those shouldn't be related to what we were seeing. So I think I'm gonna go stick this motherboard in the fridge and let it sit in there for like 30 minutes or so, and then we'll test this all over again. All right, here we go. Here's the motherboard. It's been in the fridge for about 30 minutes. You know, it's kind of cold actually. I wonder if it's gonna get some condensation on it, which maybe is not a good thing. Okay, power cable's in, RGB HDMI is in. Let's put in the diagnostic card and let's see what happens. Okay, it's running. I don't have the speaker hooked up. Now, the good thing so far is it hasn't stopped, first of all, and I just saw the orange and the purple color. So that's working. Maybe this is fixed. I mean, I don't know. I have the different RAM in here. I have this other chip in there. I'm just gonna leave it as is. If this is working, it is staying exactly like it is here. It's gonna go in the case. I gotta keep my fingers crossed. The RAM is warming up, but the rest of the board is still very cool to the touch. All right, it just beeped because the diagnostic test passed. Put the floppy drive controller into the board here and pop out the RAM card. What disk is even in the drive? Okay, we have Fat City in there. Let's turn this on. Is it gonna work? Is it not gonna work? I don't know. It's a gamble. Anything could go wrong. It's freaking working. It's freaking working. I mean, I should be happy, right? I'm just not sure because this thing has been, it's really testing my ability to fix anything, but it seems to be working. It seems to be working. All right, with this cool motherboard, I'm gonna put it back in the case with the keyboard and everything, and we're gonna see this machine operate for the first time in who knows how long, fully assembled. And here it is. The Apple II clone is fully assembled. All the screws are in. This thing is actually back together. So let's power this on. I have an actual CRT hooked up here, my Commodore 1084 over composite. There it is. Yes, excellent. Now the reason why I didn't boot automatically to the floppy disk over there is because I have a SmartPort emulation card in there. It's a Grappler Plus. That's a totally different video. I'm not going to get into the specifics of that, but this thing here has an SD card in it. And if I type PR number 4, I think it is, we hit enter, there it is. Total Replay loading up. And I have a 64K or the language card installed with, of course, the diagnostic ROM disabled. So we have 64K available for this machine. As you can see, we have excellent looking color graphics that are completely correct. And if we go to Droll as an example, hit enter, this is going to load Droll off of the SmartPort device over there. And it freaking works. It actually freaking works. This machine is fully functional. Basically took it off the bench when you just saw it a moment ago, and now it's inside the case, and there it is. It's actually running. Even though I know in my mind that what we're looking at here is this machine fully working, part of me can't believe that it is, because it just felt like every time I turned a corner where I was getting one step forward with this machine, we took 2 steps back because there was some other problem that was really difficult to troubleshoot, and we have a black screen. Don't tell me that this thing crashed. No, there we go. It was just loading a cool graphics screen there. Yeah, look at that. That's Aztec. Pretty nice color there for something that came out, well, in 1977, isn't it? And while it was an absolute roller coaster, as you've probably seen watching these last 3 parts, the ups and downs and all that stuff was just so wild. Still, it was worth every minute of it to get this computer working. And it's a real special part of history, I feel. I mean, I know there were a lot of clones. I've read the comments. Lots of people had these clones. But it's still pretty cool to know that this thing was left for dead, abandoned, with all that rust in the keyboard on the bottom plate. And now, this thing looks really good, and it works absolutely as it did when it was brand new. And that makes me feel so satisfied and so happy to see this machine saved. And of course, all the work I put into repairing this machine means I'm going to cherish it that much more. And then out of it also came the diagnostic ROM that I used many times in trying to fix this machine. So hopefully that can prove valuable and useful to the community out there. If you're trying to fix your machine, give it a try. It might give you some useful information to allow you to quickly solve the problem you're having with your machine. And with this machine fully functional, that is going to be the end of this repair series. So thanks very much, Mike, for setting this machine in the first place and giving us all this excellent content. I think is excellent, at least. And if you enjoyed this video series, I'd really appreciate a thumbs up and, of course, subscribe. And a huge thanks to my patrons. Their names are scrolling up the side of the screen, I guess, over there or over wherever, because they make all of this possible. All this content that I'm able to make is thanks to my patrons. They get early access videos and other cool stuff. In fact, they got to see these Apple II videos before anyone else. So that's one of the perks of being a patron. So if you want to become a patron, there's a link down in the description below. And I guess that is going to be that. So this thing freaking works. One more time, I got to say it. And thank you very much for watching. So stay healthy, stay safe, and I will see you next time. Bye.